Let's have a look at exercise 5. So exercise 5 mentions that MPDAs that accept by empty stack and MPDAs that accept by final state are equally powerful in the sense that they both recognize the class of context-free languages. Acceptance by empty stack just means the machine accepts whenever the stack empties out and it empties out the input on the same transition. And acceptance by final state just means whenever it empties out the input, the PDA also transitions to a final state. And it happens to be the case for deterministic pushdown automator. These two terms are not equivalent, and that's what we're going to show. So we're asked to prove that if a language is recognized by a DPDA via empty stack, then that's true if and only if the language is recognized by final state for some DPDA and the language is prefix free. And what does it mean for a language to be prefix free? It just means for any two strings in the language, one is not a prefix of the other. Okay? So let's have a go at proving this. So we're first going to assume that this is true. We're going to assume that the language is accepted by a DPDA by final state and is prefix free. And we want to prove that this language is also recognized by some DPDA by empty stack. And how we can achieve that is we can basically take this DPDA that we already have, which accepts by final state, and modify each final state to also empty the stack. So we're going to prove this by showing how we can construct the new DPDAP. So how the new DPDAP is going to work is we give it a new start state and we give it a new bottom stack symbol, say $. What P will do is it will push Z to the stack, where Z is the bottom stack symbol for P prime, and then it just does whatever P prime does. We also modify the transition function such that whenever P would go to a final state, P prime instead goes to a new state whose entire objective is to ignore the input and then whatever's on the stack, pop it off. So all this does is drain the stack until the stack is totally empty. The only time this modification could cause an issue is if there's transitions leaving a final state. So if there's transitions leaving a final state, if they never come back to a final state again, then that's okay, right? We can just ignore that these transitions ever existed. But if it were ever the case that you enter a final state, leave it, and then come back again to it later, that would imply there's two strings in the language, x and y, such that both are accepted, and x is a prefix of y. Because if you go to the final state, that means you've accepted x, and then if you leave the final state, read some stuff, and then come back, then if you accept that new string y, then x has to be a prefix of y. But we know by the fact that L is prefix free, that's not something we have to worry about. So we can just kill these transitions freely without modifying the language that we're given. So that's why we're allowed to do this construction, and that's why we can create a new DPDA that accepts via empty stack. Now we'll assume that the language is accepted by some DPDA by empty stack. This time around the modification is easy. Essentially what we do is we look at any transition that consumes the bottom of stack symbol and make the destination state under that transition a final state. Then it's pretty clear that if a string is accepted via empty stack, then it's also going to be accepted by final state, right? So that means P prime will satisfy the property language L is equal to the language that P prime accepts under final state acceptance. What we also have to show is that L is prefix free. So we'll suppose L is not prefix free. That means there exist two strings in the language, x and y, such that x is a prefix of y. Now because L is n of p for some DPDA p, that means both of these strings must be accepted by a DPDA by final state, by empty stack. Now because it's a DPDA, that means when it reads x, or when it reads the part of y that is the same as x, it has to be in precisely the same state, right? It can't do different things because it has to be deterministic. Now the problem with that is, by the definition of PDAs, you always have to pop a symbol off the stack and then do something else. So when we read x, the stack has to be empty because x is in the language. And because the stack is empty, that means the DPDA can't possibly do any other transitions. Now that's a problem because if we tried to read y, which is indeed in the language, we read the part of y that's equal to x, we empty the stack, and then we can't make any more transitions. So that means we terminate immediately, but the input isn't fully read as y equals x beta for some non-empty string beta. This means that y is not accepted under the definition of empty stack acceptance, and therefore y is not in the language, which is a contradiction. Hence it must be the case that L is prefix free. Hence this demonstrates that empty stack acceptance for DPDAs is of equal power to final state acceptance for DPDAs only if the language is prefix free.